So hello, my name is Philipp Tomsich. I've been working with the software groups within RISC-V for a year and a half now, or slightly over a year, taking over the software HC as its chair middle of last year, and we've seen a lot of change in that time. So we have started out trying to support the various task groups that were out there doing their new specifications, and moved beyond that into enablement at first. So just as Mark had described before, RISC-V is very much a hardware-driven organization. However, hardware without software is a nice academic exercise, at best. And the role of the software organization within RISC-V is to ensure that we have a usable ecosystem. An ecosystem that makes the output of the hardware groups usable for software users, usable for applications, while at the same time supporting the hardware development effort. Now, RISC-V achieved a lot of goals last year. A lot of goals that have added a number of features. So we had crypto coming out, a major innovation. Cryptoscaler at this point, everybody's waiting for crypto vectors. We've standardized or ratified the vector extension. In fact, we actually have 2 different vector extensions deployed in the field. Just yesterday, we heard about 071 being in a lot of the accelerators. One of the most common boards out there, the Allwinner D1, is also based on 071. 071 is a draft specification. So everybody who's developing hardware now is based on 1.0. However, 1.0 is not exactly binary compatible. So one of these challenges that we are facing and that we're working on as an ecosystem, as we're evolving hardware, as we're evolving software, is that there will be different versions of that out there in the field. And we as a community need to support that. We need to create the infrastructure. I'll be talking a bit more about that in detail later on. And I see a couple of toolchain developers out here in the field and OS developers in the audience. You exactly know what I'm talking about. Dynamic discovery, indirect function support, discovering features, choosing the right code paths, fat binaries. All of that is playing into our environment, and we need to drive that forward in order to support our innovation. We have a couple more major extensions that have come out. Hypervisors. Hypervisors was ratified. We just validated nested virtualization on top of our hypervisor support. CMOs, PBMTs, support for the operating system. Actually, it was kind of amazing how far we got as a community without having standardized cache management operations. There were multiprocessor systems out there, but no standardized operations. Now this has been caught up. We're enabling it. It needs to flow through the entire stack. If you look at the mailing lists at the moment, there are patches out there for binutils, there are patches out there for Linux. There's a lot of discussion going on about that, in part because, again, we have more variation than some other architectures that were drawn out by one company on the desk and in centralized planning. Because many of our vendors already had their cache management operations out there, and they were not exactly the same as the standard ones now. And a lot of the software effort is going into supporting this. So if we look at the entire stack, I'm showing this slide every time I'm up here. We have a couple of stakeholders throughout our system. Mark has drawn up the software stack, bottom to top. What do you need to run an application? But if we take a step back, software is really the one aspect that everybody needs. So we need it in pre-silicon validation. We need it for the architecture development. Pretty much every second talk the last couple of days was about architecture exploration. What does that mean? Well, you need the simulator. You need the compiler support. You're trying the application on top of it, and then you're collecting data. So software is at the heart of everything. You need it from the chip development, through the enablement, the validation, the end users. Really, RISC-V is a software project. Everybody is looking at RISC-V as a hardware project. Hardware is central to it. Hardware is enabling the software. Hardware is allowing us to drive the innovation. But in order to put it on the desk, to put it in the data center, we need the software. So software has 3 parts to it. Mark is going to throw something at me in a moment. as soon as I come to the word fragmentation, so I'm better standing over here. So we're trying to foster adoption and innovation of software. If we have working OS images that work out of the box, single system images that you can put on pretty much any evaluation board that you find, we will have people come to our ecosystem. They will get their OpenJDK, Unleashed, Unmatched, whichever board they get. Amazon, eBay, Taobao, whichever platform, or trade shows. They'll just download the image, run it, put the application on it, play around with it. This is going to bring people to us. So we need to get that out-of-the-box support there. Part of the ecosystem effort that software is today managing is making sure that there's not too much obstruction, distraction in getting these things on. Because there's market forces at play, competition, sometimes just pride. And we're trying to work through that. We're a community, we're getting together, we're discussing that, we're making sure that these things get resolved, even if they already escalated on public mailing lists first. But at the heart of all of it, it's managing fragmentation. So fragmentation is something that just happens because it's what delivers innovation. It's what delivers differentiation. So if you put some new functionality in there, people need to use it, otherwise you could have saved the silicon area. On the other hand, if you put it in and people start using it, not everybody will have that specific functionality. So fragmentation is a way of life. It's what drives us forward. It's where our differentiation comes from, where our diversity comes from. And this is really at the heart of RISC-V, because it's the one ISA that offers mix and match, that offers this dynamic, frequently occurring innovation. And you could call it a software headache, but actually it's an opportunity, because people contributing can try out these new features. We just need to provide the infrastructure for it. And finally, once we've done that, and once people provide new functionality, we can deliver optimized software support. So we've made great strides and great progress on this over the last year. I'll try to be a bit of a cheerleader for RISC-V. Usually, I'm a little bit glass half full, but actually it's about time to say we've done great. We've done pretty great. So we have upstream support for vendor extensions. First extensions in flow. We're getting all of the Allwinner D1 stuff, all of the Alibaba T1 stuff upstream together with them. We have vendor extensions from Ventana. The Sci-Fi people have already mentioned that they'll be putting some of their CMO extensions and similar on the list. So we're getting all of these distinct extensions on there. And there was just recently a poll running on one of the lists, a questionnaire asking vendors whether they had custom extensions, whether they wanted to get those upstream. And all I've heard, there was pretty overwhelming responses. A lot of people doing custom extensions, many of them actually wanting to support that. And now we have built the consensus across the groups. I hope that the pull request on the conventions document was just merged. So, and I see a thumbs up there. So we have a common framework for QEMU, for LLVM, for GCC to get X extensions up. And by the way, that starts with simple things like naming. How do we make sure that the mnemonic space doesn't overlap? Do we have vendor prefixes? How do we register that? And that was months of discussion between the various companies. Another big thing, and I'll go into that in the next presentation on the ecosystem a bit more, we have OpenJDK support. So RISC-V has barely any data center silicon. So some will be coming out soon. We have a few boards, but we have OpenJDK support at this point. It is merged. It will be in the next version. It is not the final version. So some of us have been following the ARM story back there and contributing to that. It took about 3 years to get really optimized support for Java on AArch64. But today on RISC-V, at the stage where we're in, we're having the support. Huawei contributed the initial version. There was some work done at Alibaba. There will be optimizations coming in. some of the CB extensions, the J extension work. So this is going to evolve over the next 2 years or so. But we have basic, functional, decently performing support that has both of the compilers implemented in Hotspot. One of the areas we've been working on, and one of the hottest areas, is unified discovery. So maybe it's a bit premature to call this a win yet, but it's going to be finalized this year. Unified discovery is, how do we figure out as software what we're running on? How do we encode the messages? How do we get the messages? How do we pass them so that the kernel knows, well, these extra extensions are there. We need to report that to the software above. How do we notify the user space that the extensions are there so they can pick the right libraries and the right functions in the libraries? But unified discovery has been a task group growing out of TechConfig, just recharted, that has a draft specification. They're working on finalizing that, getting the buy-in from all of the groups, and we will have that done by the end of this year. So indirect function support is playing into that. A big thank you to everybody who worked on that. So this was contributed, this is in glibc today. The infrastructure has been tested, it's working, and that really gives us optimized support. We have optimized string functions in there. I'm calling out to the optimized string functions because I'm a big benchmarker myself, and they really improve our scores on some of the industry standard benchmarks like spec. And a lot of the money that's flowing into RISC-V today is flowing into it and new product development with the goal of really getting into the data center where string functions matter. Autovectorization has just been contributed by one of our Chinese members. It's not merged yet. There's a lot of work to be done. But they dropped a 1.2 million line stiff file over our heads that now is getting cleaned up by a number of companies. This is autovectorization for GCC. We had autovectorization done by BSC. We saw the talk before for LVM. But most of the people who are using this for benchmarking in a data center environment, who are using this on a desktop environment, still use GCC. For a simple reason, that it's the system compiler on Linux. And for these people, we're getting autovectorization now too. And before that, as I said, BSC and others, I think it was Codeplay, it was Sci5, we're working on the autovectorization for LVM, and that has been there for a couple of months as well. We have nested virtualization. Again, validated in software. So we have a hypervisor extension, and that hypervisor extension can't just be used for the small, simple use cases, but you can use it in a cloud hosting environment as well with nested virtualization. We have optimized cryptography today in OpenSSL. There's a couple of patch sets, one using the bit manipulation extensions, so CBB, CBC, CBS, another one that is focused on using scalar crypto. This is all going to get upstream this year. This is all going to be merged. And with that, we're getting end-to-end performance workflows. So we'll have the software to test, and we're also getting modeling now. So we talked about Sparta. We talked about having our alternative to Gem 5, having our own dedicated workflows, where we will be modeling off-core and in-core functionality. We're working on the performance analysis tools. Some of them are available. Some of them will be built in order to have traces and visualize these. And with that, we really have those three pillars of software done. So the second part that we're working on and that we're trying to support as a software agency is domain-specific extensions, where we are working in a number of application areas. And that's what Mark alluded to before. We're founding a second HC. We're having more groups, people who have AI knowledge, graphics knowledge, giving us input, identifying gaps, identifying benchmarks, and telling us where we need to go. We're working on platform standardization. I'll have a few words on that, but the software ecosystem is huge. Let me put it that way. There's a lot of projects. There's a lot of ISVs. They all need to be brought on, and if everybody needs to support everything, they will be going mad. And eventually, they will be complaining. We need to keep them happy. We need to give them a return on investment. And the easiest way is to say, well, you can support everything. You can have dynamic detection, as I said before. But we also have a common set of functionality. If you target that, you will run on pretty much anything that's off the shelf. And at the same time, we tell the hardware vendors what they need to include in order to meet that software contract. And finally, we're trying to build a contributor culture. And again, we've made great strides in these three areas as a software group. So, as I said before, we have the upstream support. One of our goals has been accomplished there because this was a huge area of contention, believe me. Profiles and platforms are simplifying the developer journey. Profiles are finally in a draft. We have something to work with. Everybody's happy about that. It's making using a compiler easier in the future, but it's also allowing us to have a much easier discourse about what the platform is and how it fits in. And finally, we're having all of our member companies coming together. This is really at the core of what the Software HC is doing, and I can only invite all of you to join these calls and also to join our SIGs. We have contributors working on all of the projects that are listed here. So we have a SIG working on Android. They have a partially done Android 12 port out there. They are working towards getting this upstream next year, getting this merged into AOSP at some point late next year, passing the tests, optimizing more and more libraries. You might have seen the news. There are companies already demoing Android on RISC-V boards. Linux support, well, just check the mailing list and see how many new patches are out there, how many new features are being worked on. We're working on getting feature parity and performance parity, most importantly, well supported in all of the compilers. QEMU is our dedicated emulation support today. I was just looking at numbers last night. So my team is actually running benchmarks on QEMU all the time. So big software benchmarks to qualify the compilers. And we're having 350, 400 MIPS, 450 MIPS emulation performance with that when it comes to just doing functional verification of software. So we have a very fast and performance solution. OpenJDK is there. It's something where I invite everyone to actually try it out, to see where the gaps are, to see where the performance is in order to make our OpenJDK journey better. And finally, OpenSSL, which is the key crypto library for a lot of users, has been optimized. Now, with all of this, just a quick outlook, a very brief outlook onto one of the biggest topics for the future. So I said profiles and platforms, helping ISVs to come to the platform, helping people to port. So most that we heard before was focused on the big platform, Linux, data center, automotive head-end. But there's also the embedded space where we can do better. So what we're doing in platforms is really not one platform, we're doing two platforms. We're doing an embedded platform, RVM CSI. Think of it as an abstraction layer for microcontrollers, for your peripherals. And we're doing OSA, which has as an intermediate step that SEE, which is your rich operating system platform. The goal on the one hand is source code compatibility, and on the other side, we're aiming towards binary compatibility. Bare metal languages, bare metal applications versus anti-OS distributions. And you have to think of the entire software effort on that side as being structured along those two lines. We have both parts of the ecosystem to deal with. We need to move both of them forward. The users that just want to get Linux on there should have a good binary compatibility story. Notwithstanding innovation, notwithstanding differentiation, but out of the box, we need to get the applications on there. While RVM CSI is all about moving code between vendors, making sure that the SDKs are interoperable in order to make it easier for people to come onto our ecosystem and stay in the ecosystem, even if they may choose vendors, even if they may choose devices. And that said, this was just a very brief overview of what software is doing today. Some of the challenges, you've seen the roadmap before, there's plenty more, but talking about it for hours wouldn't help us. Just come to the meetings, join the SIGs. work in the areas you're interested in, because we have all of these things. We're continuously getting improvements out. We're having a few achievements every month, every quarter, to solidify our ecosystem. But what we need is our membership. Just as Mark said before in his call to action, join up. Most of you are members. Most of you are either individual members or member companies. Come to the meetings, join the SIGs, and help create the software ecosystem as well. The software ecosystem is at least as important as the new hardware solutions, because you might get the hardware solution out, but after that, the software work starts. Thank you.